In this next video, we're going to put together what we learned about structure union, mostly structures, and we are going to expand it to merge it with what we learned before about dynamical arrays, just regular arrays and stuff like that, dynamical memory allocation. So first thing I would like to do is I would like to jump in the code and define a new structure. So I'm going to call it struct player data. And it's going to hold some data about a player and their score, okay? So char star name, the name of the player, and then an int representing the score. Something very simple, okay? We're going to type def this, type def struct player data, and we have a new data type that's convenient to use with a shorter name. Okay, so we already seen how to use the structure, so I can say player data player one, and then I can say player one dot name equal parzival. Okay, and then we can set the score to player one dot score equal 110,000. There we go, and we have recorded here that the player whose name is Parzival scored actually 110,000 points so far. Okay. We can of course write a function to display this information, write functions to compare player data based on their score, okay, for example to order them or something like that. But this, we already covered that in the previous videos. What I want to insist on here is, once I have this, how do I manipulate like an array of those data structure? Like for example, I want to create a leaderboard, right? So I want to say I have a player data leaderboard, and it's going to be an array of 5 different player data, and that's it. I use the new data type player data, the name of the new data type, as I would use the name of the data type int, for example. If I can make an array of 5 int, I can make an array of 5 player data. If I can make a pointer on int, I can make a pointer on player data. That's what we're going to do next, okay? But then how do I populate this array? Well, I can go ahead and say leaderboard index 0 dot name. So I use a dot notation here. Leaderboard index 0 gives me access to a struct. And then when I have a struct, I use dot as the name of the field inside of it. And I can start populating all of my player information. Oops. Work possible. Leaderboard. We're going to do cut and paste because this is going to be tiring very fast. So there we go. Score equal 110,000. And then we can keep going like this, and we can fill all the entries in the same manner. Okay, so leaderboard 1, name is going to be Artemis, and score is going to be 109,000, and so on and so forth. Okay, so the way that we use an array of struct, same way we use an array of int, okay, with the exception of that dot notation. Nothing fancy here. Let me get in the routine of compiling this, just so that I don't let a little typo slip. There we go. For example, leaderboard undeclared first use in description. Did you use leader underscore board? Leader. Yeah, this is a typo. This is a typo. Here we go. Leaderboard. That's exactly what I want to avoid, okay? Like talking for like 30 minutes on a piece of code that has an obvious flow, and everybody's focused on that, and you guys are not listening to the rest because this is, the bug is becoming bigger and bigger as the time passes on the screen, right? All right, so make sure we have no typos. So we have like an array here of 5 elements. We have populated the first 2 elements. You can guess what's going to come next if we populate all 5 entries of the leaderboard. What do we do if we want those arrays to be dynamical? Well, we're going to use pointers. So let's step back one step. How do I use a pointer on a data structure? Well, I already showed that in a previous video. I could say player data ptr So player data star PTR, and then assign to PTR the address of, for example, P1, or assign to PTR the address of leaderboard index 1. Okay, wherever I have a struct player data, I can actually take the address of that struct player data and assign it to my pointer PTR because it's a pointer on player data. Okay, so that's interesting, but I am pointing to an existing structure. How do I create a structure dynamically? Well, I can use my pointer and I can use a malloc, right? Remember what we said all along about malloc? Malloc doesn't care what kind of data type you're trying to allocate in memory. It just cares about one thing. How many bytes do you want me to allocate for you? So we just need to specify size of, okay? And we're going to say size of player data, and that's it. Now we're going to allocate enough bytes, to store a player data variable, player data information, and we are going to get the address in PTR, and we can go ahead and say PTR, so PTR syntax that we already introduced, okay? PTR arrow name equals H. Oops, international keyboard. There we go. Name equals H, or if I don't like the arrow notation, star PTR, the reference PTR, and then use a dot notation. Score equals 108,000. Okay? So I can allocate one structure like that, and the way that I will free it when I'm done with it is just free PTR, as usual. I can allocate one structure, but I can go further. My goal was to have a dynamically allocated array of such structure. Well, how would that be different? Well, let me allocate dynamically an array of such structure. I could say, for example, and I'm not going to call it PTR, I'm going to call it player data star, and I'm going to call it leaderboard 2. And then I'm going to allocate dynamically again with malloc. What's going to be the difference? The difference is going to be that this time I don't want to allocate only 1, but I want to allocate, for example, 5. So I'm going to make the parallel to my array of 5 player data that I had before. Now I have a dynamical array of 5 player data. When I'm done with it, I want to deallocate it. Deallocate free by using free leaderboard 2. If I want to access something inside of it, sure, no problem. Leaderboard 2 is a dynamically allocated array, right? So I'm going to access an element at index 0. That element at index 0 is a structure. There we go. I can use the dot notation. So leaderboard 2 index 0 dot name and leaderboard 2 index 0 dot score. Here we are. Okay? All right. So a lot of this, I'm going a little fast over this, but a lot of this is old news, okay? In the sense that, like I like to tell my students, if you know how to do something with an int, you know how to do it with any data type. Like, how do you allocate dynamically an int? Malloc size of int? Well, what if it's a double? Malloc size of double. What if it's a player data structure? Malloc size of player data. What if it's a union called player data? Well, malloc size of player data. Okay? So once you understand how to use a basic primitive data type like an int, if I teach you how to declare your own data type, create names that correspond to your own data type, then you just substitute the name of data type to the int, and you're done. Okay, you already know how to do all those things. Declare a local variable, declare a parameter, declare a pointer, allocate a dynamical array of elements of that data type, and so on and so forth. So it's very important that you connect the dot like that. As you learn new stuff, you connect it to everything that you knew already how to do before, so that you just add one tool to your arsenal, and suddenly you can do a multitude of things, okay, because you successfully connected it to everything that you learned before. So that's it. We have dynamic memory allocation here in the form of array. We have dynamic memory allocation in the form of one variable at a time. The next step would be for us to say, to go one notch further and to say, I don't want to just dynamically allocate, those structures, one or more of those structures. I want to maybe dynamically allocate them, but I want inside of them to find something that's going to be also dynamically allocated. And the name here, the name field, is a good candidate for that, because so far I've been using string literals. And it gives you the illusion maybe that, strings in C are super easy to manipulate. I just put double quotes, the name, etc. But this is cheating. What about instead of allocating a string literal like this, I was allocating the memory to store that string, and then copying the string inside this newly allocated piece of memory. Right now, the string literal cannot be modified. But if I allocate them by hand and I copy Parzival inside the newly allocated string, then I will be able to modify them later, like, for example, change that uppercase P to a lowercase p or something like that, whatever I want to modify inside the string. So how would I go about doing this? Well, instead of writing p1.name equal Parzival, I would say p1.name equal malloc size of char times, and then I need to know how many characters I have here. So I have 1, 2, 3, 4, 5, 6, 7, 8. 8 characters plus 1 for the end of string marker. There we go. That's the size of my malloc. So I'm going to add even the conversion to char to be super clean. There we go, char star. All right. And then once I have this, strcopy inside p1.name, I want to copy the string Parzival. Okay? And that allows me to have dynamically allocated inside of P1 the array of characters that I'm going to use to store the string Parzival. So when I use P1 like this, doesn't make much of a difference. When I'm done later on, after I'm done like playing with P1 as much as I needed, I have to remember to do P1, free P1.name. But other than that, nothing really changed. But what about if I have an array like this? Well, it's going to be the same thing, but for every time I was assigning a name as a string literal, I'm going to have to do this work up here. Okay? So it's going to be done here for Parzival, then it's going to be done for Artemis on line 29, and so on, so forth. And when I'm done with my playing with my array here, I'm going to have, for example, a loop here for int I equal 0, I lesser than 2, sorry, I plus plus 2 just because I have only 2 elements in my array, and I have to remember to free the memory I allocated. So free leaderboard of I dot name. Okay. And just for the sake of showing you the complete example here during this video, I'm going to take this and I'm going to adapt it to my leaderboard 0.name here. There we go. And then I'm going to do the same thing for leaderboard index 1. So this is leaderboard index 0, and then leaderboard index 1, I'm going to use a cut and paste to speed things up a little bit. There we are. It's going to come right here and replace the string literal Artemis. So Artemis, we have 1, 2, 3, 4, 5, 6, 7, plus 1, 8 characters. So I can reduce a little bit here the size of my buffer, and this is going to be leaderboard index 1, it being equal to Artemis. Okay? So if I do this, then when I'm done, so this is the first part was just one variable, okay? Then we did that with an array right here. and the array was statically allocated, not dynamically allocated. And now we continue moving through the examples. So what did we have here? We had a dynamically allocated array. Same thing inside the dynamically allocated array. Inside the dynamically allocated structure, there's only one struct that was dynamically allocated here. I'm going to find, oops, wrong cut and paste. I'm going to find a str copy and again, one of those. So instead of H here, 1, 2, 3, 4 letters. So that's going to be a malloc of 5, and then copy the string H instead of Artemis. And of course, it's not leaderboard index 1 anymore, it's ptr here. So I have a pointer and a struct, and I am changing the name, allocating dynamically. So the struct itself is allocated dynamically. The pointer inside is allocated dynamically, okay? And when I want to free them, I free first what's inside, and then I free the whole structure. So free ptr arrow name after I am done using it for however long I want it, okay? And then the last example, we have our array, dynamically allocated array of structures. How is that going to work? Exactly the same way. So I'm going to cut and paste this once again. The name is once again here H. And the only thing that changed is where is this dynamically allocated field? Okay, so it's leaderboard 2 index 0. There we go. So leaderboard 2 index 0 dot name equals a malloc, and then string copy inside leaderboard 2 index 0 dot name, the string that we want to copy. And when we free again, first we free the inside, so we use it for as much as we need, and then we free leaderboard 2, and there's only one element here, so I'm just not going to do a loop, okay? I'm going to do leaderboard 2 index 0 dot name, and then you free leaderboard 2, which is a whole array, okay? So again, this video is going a little fast, so don't hesitate to post in the forum or come by to office hours to, if you need some explanation. We'll go back over that material a little slower. But this is because we already learned how to do all those things. I'm just substituting, the new knowledge of how to declare a new data type, and then I'm doing all those scenarios where I'm dynamically allocating something of type struct, so struct player data, okay? And then I'm making not only the structure dynamical, but I'm making an array of them. Then I'm making the array of them dynamical. Then I'm making a field inside the structure dynamical, and you see how I repeat the same patterns that I've used before over and over again. All right, so we're going to wrap it up for this video. As usual, thank you for your attention, and I'll see you in the next video.